And now quantum mechanics has a formula for these things, for this probability. So we can test whether this is true. So let's do that. This is the so-called Bell inequality. So if quantum mechanics is true, the following should hold. Let's see that. If QM is true, well, there should be a problem with this inequality. So let's see what it happens. Let's see if it's true, this inequality. Is it really true? Well, the left-hand side would be, given the formula that we had, 1/2 of the sine squared of theta AB over 2. So let me just emphasize, this was derived using local realism. Local realism gives that. So you do the experiment, get these probabilities, and if realism is true, this should hold. Let's see what quantum mechanics has to say. Let's plug in the values that you get from quantum mechanics. Now, we calculated this probability. We put the first term. Here is sine squared of theta AC over 2, and 1/2 of sine squared theta BC over 2. So does that work? Does that always work? Can I orient this axis in such a way to disprove EPR? And in fact, it turns out to be quite easy to do that. So you choose 3 vectors like this, A, C, B, C. So C here, A here, and B here, I believe. Yep. So put an angle theta here, an angle theta here. And then what do you have? Theta AB would be 2 theta. Theta AC would be equal to theta BC equal to theta. That's a pretty nice, simple choice of angles. If you choose these angles now, let's see what happens with our inequality. So you get 1/2 sine squared. Theta AB over 2 would be theta. Is it less than or equal to this? Well, these two become the same, so you get sine squared of theta over 2. Violated or not violated? Is it true or false, this, for all theta? What do you say? Yes?
If theta is less than pi, that's not true.
Close. It's not true for small theta. So, you know, if you're this and you're desperate to know, the thing you have to do is assume theta is very, very small. See if you get in trouble. How much is this? 1/2 theta squared. One second. Have this one. Yeah. And how much is this? This is theta squared over 4. Sorry, I was not seeing it. Sine theta for small theta is roughly theta. So here is theta over 2 squared, but here's 1/2 theta squared. And it's false. The 1/2 theta squared is not smaller than 1/4 theta squared. And in fact, for theta equal pi over 2, I think this is an equality. because theta equal pi over 2, you get on the left-hand side 1/2 less than or equal than sine of 45 degrees, which is correct. So it's an equality at pi over 2 fails below. So it was a shock that if you could do an experiment in quantum mechanics and an experiment with correlated entangled particles, that you could measure these probabilities, these correlations, and you would obtain a result that actually contradicts, for certain alignments of your experiments, the assumptions of local realism. So it was a great result of Bell to show that quantum mechanics is in contradiction with local realism. There's no way to keep the ideas of quantum mechanics and put hidden variables and assume that there's real values for things and that there's no effect at a distance. It would all be contradicted by an experiment. That was done later, and the definite version of the experiments around 1980 or 82 by Alan Aspect and others. Very clever experiments, worth reading and understanding, but confirmed that the quantum mechanical result is really true by measuring correlated pairs, and these inequalities are violated.